recording.
All right, hello. My name is Phil Jochimsen. I'm doing an intro to Terraform and infrastructure as code. You will note there is another intro to Terraform presentation that Brian Hill has in the on-demand section. He goes into like a lot more depth than I do. I'm doing a little more of the why and a quick live demo, and he's got some really detailed stuff that all of you should probably check out. Again, my name is Phil Jochimsen. Thanks for attending IT ProConf Virtual 2020. And we'll get in here a little bit. And I want to quickly get to some of the, let's see if we get actually the next slide. See if my Google slide loads thing here live. That is fancy. Try a refresh on that then. One more time. All right, so it doesn't like my second slide. Let's go back to the other view of the second slide then. All right, so just doing a quick overview here again. Want to hit why. I'm going to do a quick demo. Then we talk a little bit about what is infrastructure as code, why is that important, what's Terraform, and then I'll do a little bit of a longer demo after that. So I shall try to resume here. Slides, and like technical difficulties doing it live. So the big thing here, trying not to bury the lead. Why you should care about infrastructure as code and Terraform. It's possible to build your own software as a service or platform as a service on top of infrastructure as a service. I'm gonna let that sink in a little bit. We consume those kinds of services, software as a service, platform as a service, because we don't want to necessarily manage everything. What we get from that is, of course, a limited or a reduced feature set than if you had built it yourself. What Terraform as infrastructure as code allows you to do is build all that stuff out, get yourself a platform as a service, but also have the source code then for it. So you can go and change whatever you need to. Many times, you know, part of the limited feature set we get or reduced feature set we get from platform as a service, you know, it'll have like a maximum of 10 of something, whether that's, you know, megabits per second for a network throughput or number of servers or number of certain types of DNS entries, etc. And those might be artificial limitations imposed by the provider. If you're building off of infrastructure as a service and you own the code to get your platform or to get your software as a service, then you can make changes there. So this one's really huge for me. It's a really important idea. Second one here, kind of this solving this problem of the always more. It's like in the future, you're going to have more environments, more customers, more changes, more security issues. And the answer is yes. So we need ways to try to be able to manage that stuff, you know, with less overhead. So the quick demo we're going to get to right away here is creating an EC2 instance in AWS, and then we're going to go destroy everything after that. So we go through a couple of commands with Terraform. The first one we do is called Terraform init. And what this does is it downloads in this case, the AWS provider. And the provider is really the thing that understands what kind of API calls Amazon has, what kind of API calls it might need to make in order for it to actually execute something. We then do the major command you will use Terraform a lot with, and that's Terraform plan. And there's going to be a lot here that scrolls past the screen, and I'll go back and highlight a little bit of that as well, so we can see what it looks like. But basically, we've told it to make a couple of things, and you'll notice right off the bat there's a whole bunch of these things that say known after apply. And that's because these are identifiers that get created after the thing is instantiated. So like Amazon resource number, we don't know what that is until the thing actually comes into existence, just like the IP address isn't known. You notice a few are picked out though. So AMI, the Amazon machine image, that's known, as is the size. And you'll see when I actually do the Terraform file here, and this is literally all I did for this file. We've created an AWS provider in US East 2, that's Ohio. And we picked out the AMI, the instance type, and we gave it a name too. You can add more things here, but this was one of the cool parts. Like there's only a handful of things I defined there. And you're going to see that the plan says we're going to add one thing. So once I've done that, then I can use Terraform apply, to actually execute the thing that we wanted to do above there, which was to add one item. see if I can bring over my other EC2 console. And let's see here. Yes, we would like to add those changes. What's going to happen is that we're going to see that start to come into existence over here. I hit refresh faster than it does. So this is actually, you know, I run this from the command line on my computer, and this is in Amazon's console making a thing for me, again, with that name of example 1. I think there's still some, I get this right, yeah, the status checks do take a little bit of time for them to come up completely. So it'll be in that initializing state for a little while. So as of this second, the thing wouldn't probably be able to deliver a web page, but it should be reasonably soon. A T2 micro is pretty small, so it's not necessarily the fastest thing to start up, but it does go pretty quick. And then once we're done with something like this, like let's say I've proven that, oh, that's what I needed, or I was able to get what I wanted out of that, then I'm actually going to tear this thing down because I actually know what I needed to get. So I'm going to make a plan for destroying it. And then I'm going to give it a specific file name here. So I'm going to call this example.destroy.plan. And you're going to see a very similar thing to what we had before here, where there's going to be a lot of information, but it's also going to go from one add, it'll be to, here you go, one destroy. You'll also see that all those to be determined kind of things did get filled in, and they're going to go now to null because we're going to take this instance out of commission. So I want to apply the example destroy plan, and that's pretty much it. That should take this thing out. And we'll see how this goes. I think the same thing that the spinning down, it takes a little bit of time as well. Yeah, basically it's already going to start moving towards coming down into shutting down status. Give that a sec to go through. There you go. Okay, so that was the first part. I've got again a little bit longer example here at the end. What I called my directories. There we go. Okay, so we'll get to that one in a second. All right, back to the slides. So we did this. We created a thing. We destroyed everything. So infrastructure as code. Kind of like, what is our big thing here? We've got a little bit of examples, benefits, future workloads, some changes. The idea is to apply that software development paradigm to infrastructure. We're managing it as code, so we do things like we use version control, not clicks through an interface, and we get a lot of very useful things from that. Some examples, again, you can do this yourself already with sets of scripts. There's configuration management tools. There's infrastructure automation, orchestration, etc. There's a lot of different levels at which these things operate. In this case, Terraform operates at a pretty high level of abstraction, right? I'm really far from the actual EC2 instance. I don't even know what the API call is that it actually made in order for it to create that. And I didn't need to know that. I just told it I want an EC2 instance, and it figured out what it had to do. Some of these benefits, again, managing as code is consistency, the ability to manage multiple contributors, updates, less toil. There's a good one there. You've seen the SRE definition of toil. That's a really important one. And then this future workload things we've talked before, that there's going to be more environments, more customers, and this really does help us prepare ourselves for being able to deal with that. If someone told me 2 years from now I'm going to have 5x number of environments or 500x number of environments, tools like these allow me as a contributor to scale to be able to do that myself. Some of the changes, this is a different mindset. So there's definitely a bunch of my career that we go through things and click on things, and there wasn't a good record besides the documentation we've managed to leave ourselves. But there was inconsistencies too, right? I'm a human, so I make mistakes. So we try to use machines here to automate everything as best we can, and keep people able to work on the things that they can focus on the customer, applying creativity, not doing those rote kind of tasks. For me, and maybe for other folks that are visually driven, there isn't a graphical interface, so we might need to make relevant visuals. I think I've got one example I can show you here too with that. So there's one of the ways to take some of this Terraform information to Terraform graph, and I think it was, graph viz, that you can do this where you get something kind of out of the tool pretty quickly. So there are ways around that. All right, moving on to Terraform itself. Again, Brian's talk, I will mention that again, goes into a lot of depth about how all this stuff goes together. In general, what I think of it is just that it's it's an implementation of infrastructure code. It's a tool. Other examples you've probably heard of: Chef Puppet, Ansible, SaltStack, CloudFormation, etc. There's a whole pile of things, and then there's a lot of these almost buzzwords, but like they do mean some very specific things. Declarative, meaning I tell it what I want the end state to be, and it figures out what it has to do in order to get there. Masterless, so I don't need a server running all the time. Agentless, I don't need something installed on everything in order for this to work. So this reminds me, even those parts right there, excuse me, remind me a lot of how we use Git kind of asynchronously or distributed in a manner that, if I've got the credentials and I've got access to the state file, which we'll talk about in a second here for Terraform, I can run this from anywhere. It's also a provisioning tool, so it creates immutable infrastructure. And we'll keep going. Okay, so API driven. I mentioned API stuff before, and there's like the Terraform core command, and then you get a bunch of different providers. So the AWS one is the one that I installed from that init command. But your Terraform scripts could have multiple clouds, so Azure, GCP, and then other things too. So there's on-premise stuff that you can actually take action against. VMware, Cisco, Palo Alto, just some examples. There are providers for those. And there's hundreds of them out there in their provider directory. So keep that in mind. It's possible for you to start actually, doing as code hybrid scenarios, or even like taking things that maybe required a lot of different types of glue to stick together here on campus. Maybe you can start using again, at a higher level of abstraction, one kind of glue, put those things together. There's also the Terraform state file, and again, it's kind of the snapshot. Like, what does it think I've got? State file after I created that one EC2 was, of course, I know there should be one EC2. And then we're storing, of course, the configuration code, which allows us to use things like Git and version control. So there's a lot here to this, and I'm not going to read through all of these. We'll probably make the slides available later. But you can actually incrementally add existing infrastructure and configuration into the state. So I can look at like one of the projects I work with, the Wisco CMS, and say, oh my God, there's a whole lot here that we definitely created manually or created not in the most necessarily consistent way, or in a way that I can manage if the thing needs to get twice as big or 4 times as big or 4 times as many things. But I can start bringing stuff in. So I could be like, all right, round one, we're going to start with the VPC, something pretty basic, and we're going to keep adding stuff in over time. Brian Hill, again, had some really good information about this, and he kind of showed me that like that's actually possible. Like you can do that. I tried doing this with CloudFormation when we originally launched the Wisco CMS service back in 2018, and their ability to export what you've got in order to make a config that was importable or recreatable was in beta. It was unadvertised as being beta, but it was so beta that you couldn't do it. You were basically writing a config completely from scratch. And this one plays nicely, or at least has a chance to play nicely. It's non-trivial, but it has a chance to play nicely with what you've already got. The other part here too then is just that this seems like a career builder sort of thing, that it's a very important strategic learning for professional development. This strikes me as one of those technologies where if I don't know it in the next couple of years, there's a certain part of my usefulness that is definitely, I've been past. The cool part, as you already saw, is I was using my own Amazon account, and it's because I can make these things come into existence and make them disappear pretty fast. It's a perfect example for learning. I can make dozens or hundreds of things stand up, and handfuls of minutes later, I can make them disappear if I've proven my hypothesis for getting something up and running. Challenges and barriers, yeah, the open source version really does only have one state file, and that's there's the easiest way we get around this though is either using CI/CD to be the thing that actually executes the changes. So it's a single executor then, so it's not a multi-threaded executor in that case. And then you can do some locking. Again, Brian talks a little bit about that, about how you can put the state file in an S3 bucket, or you can put it in as DynamoDB, again, in AWS to have dynamic state locking. It's also non-trivial. Like I'm scratching the surface here, and I'm still trying to wrap my head around what's possible with it. The workflow, you've already actually saw some of this. Generally, we do Terraform plan after we've made a change to our our configuration files, our .tf files, and it'll say like, hey, I think you've got, you need to make these 3 things or those 4 things or whatever, and then we do apply to actually have it do. Again, in the case of the destroy command, we had it destroy the things that were there. And then you basically head back to the top and do it again. See if you got what you needed. So in this longer demo, I'm just creating more EC2 instances and a whole bunch of stuff that you actually would probably want for a bigger application anyways. Auto scaling group, launch configuration, security groups, and a load balancer. And then you'll see, as part of this is super useful for being able to learn stuff. I can then give it one command and it'll go destroy. So let's get that up here. Console. Yeah, and I was looking up Minecraft Terraform things, which I thought was a hilarious yet incredibly timely and useful thing for being stuck at home. Okay, so this is in the second directory. There's a much bigger file here. What I did for all of this is I followed a set of examples that were given by a group called Gruntwork, and I've got links to that at the end of the presentation. You folks can go look that up. They did an awesome 6-part series on Medium about how to get started with Terraform, and then they turned it into a book called Terraform Up and Running, Writing Infrastructure as Code. And again, a lot in here. There's load balancer, DNS entry, auto scaling group, all that kind of stuff. So there's a whole bunch there, but that's fine. We do our Terraform plan. You'll notice that I'm going to do this as I'm going to actually make that as a plan file. And this is part of like one of the good habits to get into also, that the plan is at a point in time. If I had ran Terraform plan and then something happened to change, like manually over here in the console, went to manually change things, and I could apply, I could end up actually doing more than I expected to. There we go. All right, and again, our plan came back with it's going to add 5 things, change 0 and destroy that. So we'll just run this for this second implementation here, and I think again, yep. Okay, so I'm just going to read through this. The ELB got created. It's creating instances. Oh, security groups got created. And I think, yeah, right. So there we go. So this is our other 2 that are starting to come up then. This first one up here was the one that was terminated previously from our first example. And basically, after this gets done running, we're just going to make the commands to go ahead and destroy it also to get rid of it. And I think same as before, they're running, but yeah, initialization takes a little bit of time. And let's see here. Oh, this is my awkward pause part. Okay, there we go. Okay, so it actually applied, yep, creating 5 things. There wasn't anything to change or destroy. To give you an example, I think, let's see if I can do this. Yeah, so to give you an example of how this deals with changes that are done out of scope. So this is the configuration drift problem, right? So if I say, let's go back down to 1 actually, make it go faster. So I just made a change that Terraform doesn't know about yet. So that's configuration drift. That's all that where you can, I've done something manually, it's going to happen over time. Now what I'm going to get, if I run this, and I think we got to get just, yeah, and that should be applied. Okay, so if I do Terraform plan right now, what I'm expecting, I will tell you, is that I believe it's going to make a suggestion that something has to be changed, right? The auto scaling group said there was supposed to be 2 according to what's in the Terraform plan file. And here we go. So that's where that changed. So the minimum size got changed. And I think you'll, yeah, so the minimum size, that's what did that one. So if I apply this again, it's gonna, it's gonna actually do that change. I'm going to run this. I think I can run this destroy command. So we'll do plan destroy. And we'll see what this comes up with. So I'm curious if this is going to show that there's a change and then, 5 things to destroy, or no, it should just sweep through. Okay, so the 5 things probably then, if we go back and comprise this, EC2 security group for the ELB, launch configuration, and the ELB. Yep, the auto scanning group. Okay, cool. So that's everything we're looking for there. And then we just do, as you can tell, handy little command line reference there. Apply and destroy. So that's most of what I had for the talk. These were these references that I have here. This was the YouTube talk here about the composable battle tested modules. That was the one that was really impactful for how they described that infrastructure as using infrastructure as code to build on infrastructure as a service, to make platform as a service or software as a service. And I got Brian Hill's thing there, and there's what do we got? The blog posts that go to the book. Robert, did you have questions if folks had any that they wanted to type into Slack, which I believe I forgot to mention at the beginning?
Yes, people can also ask questions via voice as well, but there is one in Slack right now. With the rise of Kubernetes and native support from each major cloud vendor, is there a strong reason to learn Terraform itself or use Kubernetes for infrastructure as code?
That's a great question. So my actual familiarity with implementing Kubernetes is incredibly light, we'll say. There's a Kubernetes provider for Terraform. So this is going to be one of those things where you want to apply the tool set that you actually need. If you're able to get everything done that you need to get done with what's already provided natively in Kubernetes or with other projects that integrate with them, then there might not be a need for that. That being said, if you do a little bit of your homework and you go just hit Google and say, Terraform Kubernetes, you're going to find that there's already a whole bunch of example kind of recipes, if you will, allow me to borrow the chef naming convention, for setting up Kubernetes from scratch. So there's a lot of value though in still even adding that additional layer of abstraction to simplify what you need to do. So as an example, if you're only going to ever set up one Kubernetes cluster and do all of your work inside of it, it's possible that using Terraform isn't going to be your first go-to. If you want an ability to arbitrarily create and destroy Kubernetes clusters and all that goes along with that, then you might be looking at doing that with something like Terraform. There's more than one way to do this, but that would be one of those examples. Does that work? If not, please elaborate in Slack, and we can have more of a conversation. And also, definitely, Brian has a bunch more ideas about this, a lot deeper than I do.
Anybody else have any questions? Feel free to unmute yourself and ask if you do. I'm not seeing any more questions here, so
okay.
Thank you, Phil.
Yeah, well, thanks for everybody attending. And enjoy the rest of the conference. Hopefully, this was something you hadn't seen before, and this seems like a pretty powerful thing that, at least for the work I've got to do, that has the future to be very useful for me in the future. Thanks again for listening.